Well, now that we have spoken of the quasi-crystals, let us return to the walls of the bubble's structure to understand the morphology of the hydrogen family. Thus, let us recall that in the foam of the inflatory period, the bubbles form polygonal boundaries between neighbors. And depending on the size of the bubbles, the polygonal walls may have 3 or several sides.
However, after maturation, the foam becomes more homogeneous, and the bubbles tend to be at the same size. And generally, they are then organized in the form of the dodecahedral morphology called Br and Felon.
Under these conditions, the walls tend to become predominantly pentagons with some residual hexagons. And consequently, the flattened torus comes to fit into the 5 pentagon tops as hypocycloid.
Thus, when the inflation zone was moved to the dispersive zone, when the bubbles burst, the universe was filled with 5 volute hypocycloids.
Of course, many strings will become limit circles due to vibrational instability.
However, if each pentagonal cycloid operates in individual planes, each neighboring pentagon forms an angle of 120 degrees with the foreground.
Under these conditions, it can be seen that 3 associated pentagons can create a curve then implying in a 4th direction. There is then a blocking effect when this common and shared curve of cycloids forms a transverse ring. This ring prevents then the group of many-string evolving in limit circle. So, we see appear a notion of locking ring for each system of 3 associated pentagons.
Therefore, the first form of matter, and therefore the proton, is not formed with 3 quarks bound by the gluon, but it is the product of the combination of 3 pentagonal hypocycloids attached by a shared blocking ring. And to summarize the end of the inflatory era, as the bubbles become more and more homogeneous, the cosmic breakpoint will propagate into the galactic space, the raw material in the form of many quarks enclosed in block pentagonal cycloids.
It was then the appearance of the primordial dust, which formed the fuel of the first stars, knowing that this matter comes from the phase of the dispersive era.
Now, let's start by detailing the first nuclides from the initial stage of nuclear genesis from the inflatory expansion.
We have just seen the proton or nucleus of hydrogen, which is the first stable nucleus of the list thanks to the blocking ring of the cycloidal clover.
Then comes deuterium, which is the exclusive representative of the primordial synthesis of the Big Bang. And to describe it, let us recall some properties of tetrahedral. The angle of the center of the polyhedral has a value of just over 109 degrees,
while the apex of the pentagon is a value of 108 degrees.
As these values are very close, deuterium is obtained by positioning 6 pentagon cycloid at the center of the tetrahedral. Thus, it can be observed that the small difference in angle is distributed symmetrically in a balanced manner on the 6 constituent pentagons. Therefore, due to this angular tolerance, deuterium has a lifetime similar to that of the proton.
With the same logic of the tetrahedral angle sharing, we obtain the tritium.
But the allowable tolerance in deuterium generates then too much flexibility in tritium, which lead to instability and self-destruction. Therefore, this heavy hydrogen isotope is radioactive in its period of 12.3 years half-life.
At this stage, remember that the nuclides have their origin from the inflation area and foam structure of werfelin with a majority of pentagonal walls. Thus, we can still apply the logic of similarity between the angles of 108 and 109 degrees. Consequently, by adding 3 pentagonal groups each time, we have the synthesis of new nuclear structures such as the heavy isotopes of hydrogen.
It is observed that on the basis of deuterium, we can then go up to 4 additions. And on the tritium base we get up to 6 additions.
And therefore, it is necessary to nominate them. After the tritium, we have the quadrium of mass 4, quinarium from mass 5, sextarium from mass 6, septarium from mass 7, octarium from mass 8, novarium from mass 9. This sequence of additions is carried out as long as the nuclide remains open.
Of course, these nuclides are more and more unstable, and they were destroyed in a fraction of a second at the beginning of their creation.
Now, based on these first data, we establish a first pentamorphic rule.
Each unit of nuclear mass corresponds to a multiple of 3 hypocycloid pentagons.
So, hydrogen, with a mass of 1, has 3 pentagons. Deuterium, with a mass of 2, consists of 6 pentagons. And this first rule of mass is valid for all nuclides.
Under these conditions, the mass is the result of the inertia of the surface isolated by the cycloidal volute. Consequently, the so-called standard mass unit generally represents 15 times the area of inertia trapped by the 15 volutes constituting a tripentagonal base trefoil.
On the other hand, it is necessary to develop the notion of spin because it is very useful for approaching nuclear morphologies.
Thus, we call spin the intrinsic angular or kinetic moment of the quantum particles.
However, to remain simple, let us say that each element or particle has a shape that can have different types of symmetry or asymmetry. As these objects are rotating on themselves, they can be presented in different positions.
And by definition, a zero spin corresponds to a totally symmetrical object such as a sphere.
On the other hand, An asymmetrical object can rotate in different directions with respect to the plane of rotation, as a function of its different axes. For example, this bulging top may rotate with its ballooning in the low position, or in the high position. In this case, since there are two positions, the spin is then a fraction, which is more or less a half.
And if there are several axes of rotation, the spin will be a double multiple of this number of axes.
Under these conditions, we understand why deuterium has a zero spin due to its perfect symmetry based on a central type.
On the other hand, hydrogen has an asymmetric form linked to its morphology structured as an umbrella. With two potential positions, the hydrogen thus has a spin of more or less a half.
Although, it is this property which is used in the medical domain with nuclear magnetic resonance radiography, when the human body is immersed in a magnetic field that directs the hydrogen. And we will see that this spin will serve us abundantly thereafter to study the activities of stars, and investigate the morphologies of the elements of matter.